Hello, my little mathematicians. Today we're going to review C-70, which is adding, subtracting, multiplying, and dividing fractions. So since this should be review, I want you guys to try them, pause the video, try it, and then unpause it and come back and check yourself. Okay, so for the first one, it says, Joe Ravioli went running 3 days this week. He ran 2.5 miles on Monday, 2 3/10 miles on Wednesday, and 3 2/5 miles on Friday. How far did he run all together this week? Okay, so as always, we want to show our work on a separate sheet of paper. So let's label it C-70. And since it said how much or how far did he run all together, that's my hint that I should add. Okay, so all together, on Monday, he ran this much. And then on the next day, he ran 2 3/10. And on the last day, he ran 3 2/5. And the 3 is at the beginning is not important. It's just saying that he ran a total of 1, 2, 3 days. Okay, so first off, when I'm adding, I want to find a common denominator. So I look at the biggest one, 10, and I think to myself, can 2 and 5 both become 10? They can. So that means that 10 is my common denominator because all of my denominators can become that same number. If for some reason you don't like doing it that way, you could always do the ladder to find it, or you could just multiply your denominators and that would be your common denominator. It would just be bigger and then you'd have to reduce it at the end. Okay, so 5 times what is 10? 2. So 2 times 2 is 4. 10 times what is 10? 1. So 3 times 1 is 3. 2 times what is 10? 5. So do the same thing on top, and 1 times 5 is 5. I did this because I created equivalent fractions. 5/10 is the same as 1/2. 3/10, obviously the same as 3/10, and 4/10 reduces to 2/5. So I just rewrote each fraction in different ways so that they'd all have the same denominator of 10. Because when you add fractions, you keep the denominator the same and you only combine the numerators. So 5 and 3 make 8, and 8 and 4 make 12. Then don't forget those whole numbers. 2 and 2 make 4, 4 and 3 make 7. Now I would be done, except you can't leave it improper. So I need to figure out what 12 over 10 is. 10 goes into 12 once. 1 times 10 is 10. When you subtract that, you get a remainder of 2. So you put your remainder over what you divided by, which means 12/10 is the same thing as 1 2/10. So you still have that 7, but 12/10, I'm going to add 1 2/10. So the whole numbers 7 and 1 make 8, and then you have 2/10. We'd accept it, except technically you always want to try, if you can, to get into lowest terms. 2 can go into both of them since they're even. 2 divided by 2 is 1, and 10 divided by 2 is 5. So that means that number 1 is 8 1/5. So if you find that, that's right there, the AS. So for number 1 down at the bottom, you would write AS on your worksheet. Okay, as you can see right here, I found the AS and wrote it for number 1. Okay, so moving on to number 2. Number 2, if I look back at my paper, it says, Nuts to You sells trail mix in 16-ounce packages. Half the weight is peanuts. So the total is 16, and half of that is peanuts. That means 8 is peanuts. There's 2 ounces of almonds, 1 ounce of cashews, 3 ounces of raisins, and then the rest is chocolate chip. What fraction of the mix is chocolate chip? Okay, so let's see here. Okay, the rest is chocolate chip. So do we know how much is actually chocolate chip? No. But I know that the total is 16, and they told me all the other amounts. So I know 8 was peanuts, 2 was almonds, 1 was cashews, 3 was raisins, and then plus some other amount is chocolate chips. So let's add all these together. That's 10, 11, 12, 13, 14. And if the total bag is 16 ounces, let's subtract everything else, and that will give me the leftover amount must be the chocolate chip. So how much of the bag is chocolate chip? Well, 2 ounces is chocolate chip out of the total 16. So 2/16 is chocolate chip. And of course, you can reduce that because they're both even. So they both reduce by 2, which means 1/8 of the bag is chocolate chip. So if I find that on here, you see that that's SH. So for number 2, I'm going to put an SH down at the bottom. Okay, number 3 says Six Flags Amusement Park has found that 3/5 of its customers ride the Colossus roller coaster. Good, I do too. Of these, 1/4 ride it again. I do too. What fraction of the customers ride the roller coaster twice? Okay, so first of all, it's 1/4 of these. Well, who's of these? Of the customers that actually ride it again. So how many customers ride it twice? 1/4 of the amount of people that actually ride Colossus in the first place. So number 3 is 1/4 of the 3/5 of the people that actually ride Colossus ride it twice. So 1 times 3 is 3, and 4 times 5 is 20. Can you reduce that? Nope. So 3/20 ride Colossus twice. So for number 3, I would put an AD. Okay, now remember, if you haven't been trying any of these first on your own, it's a mixture. Some we add, some we subtract, some we multiply, some we divide. Some of them are multi-step. Try and see if you can figure out how to set up the problem first before we do it together. So feel free to pause the video anytime and try to figure these out, and then unpause it and check yourself. Okay, our next one. Number 4 says that a record album is 3/16 of an inch thick. How many albums can be stacked to fit in a box 12 inches high? What do you think? Add, subtract, multiply, or divide? Trying to figure out how many can fit inside of something. Yeah, divide. What are you going to divide? This is how much you have, and you're going to divide it up into how many 3/16 can fit in there. So 12 divided by 3/16. Okay, so when we're working with fractions and we're dividing, whole numbers go over 1 to make them both fractions. And then for dividing, we go keep, change, division, multiplication, and flip that second fraction. Okay, keep, change, flip. And then you just multiply like normal. You could just multiply across and reduce at the end, but if you want, you can make the numbers easier by cross canceling. I see 3 can go into both of those. So 3 divided by 3 is 1, and 12 divided by 3 is 4. Now on top, you have 4 times 16, which is 64. And on bottom, 1 times 1 is 1. So 64 over 1 is just 64, which means that you can fit 64 of them inside of there. So that was number 4. I see 64 right here, which is SE. So for number 4, we're going to put SE down at the bottom. Okay, number 5. In the figure shown to the right here, what fractional part of the circle is shaded? What do you think? Okay. Well, first of all, how much is the whole circle? 1, right? So if you take 1, you could subtract this and then subtract this from that answer. Or I like to add both of these and then subtract that from 1, and that will tell me how much left over is a shaded amount. Okay. So number 5, we're going to add 1/3 and 2/5. Okay. And when we're adding, we want to find a common denominator, which in this case is 15. So 5 times what is 15? 3. So 2 times 3 is 6. 3 times what is 15? 5. So 1 times 5 is 5. Now you have equivalent fractions that each have a common denominator of 15, so you keep that the same, and then combine your numerators. 5 and 6 make 11. So you have 11/15. That's how much is the white part. Now you want to know how much is shaded. So out of the entire thing, we're going to subtract out 11/15, and that's going to be the leftover amount. Okay, now when there's nothing up here to subtract from, I need to borrow from the whole number, and then I put 1 as a fraction. What fraction? We'll just pick whatever this denominator is right here. Okay, because any number over itself is 1, right? Like 10 over 10, 5 over 5, 3 over 3, those are all 1. Since you can pick any number over itself to represent the 1, why not pick whatever that denominator is so that then you can combine them and subtract the numerators. 15 minus 11 is 4. So 4/15 is the leftover amount that must represent the shaded part right here. Okay, 4/15. And if I look to the right, I will see that right here for CO. So for number 5, that's CO down at the bottom. Okay, number 6 says a recipe for 2 dozen cookies calls for 1 1/3 cups of flour. How much flour would be needed to make 5 dozen cookies? What do you think? Ponder that for a second. Okay, 2 dozen calls for 1 1/3. So how much would you need if you're doing 5 dozen? Okay, there's 2 ways you could do it. You could do 2, like double this, and that'll give you 4, right? And then you have to divide it, one of these in half, and see how much that is for just 1 dozen cookies, and then add how much it is for 1 dozen for the 2 dozen plus another 2 dozen. But that's a lot more work. What I think is easier, since you have to find how much it is for 1 dozen cookies anyway, I would do that first. So I'd figure out, okay, if 2 dozen is this much, then I'm going to take this amount and divide it by 2, and that will tell me how much it is for 1 dozen cookies. Then I take that amount and I multiply it by 5 because I don't want 1 dozen, I want 5 dozen. Okay, it would have been easy if it was like 6 dozen. I could have just multiplied this by 3. But no, they had to do 5. So the first thing I want to do is take how much it is for 2 dozen and divide that by 2 to figure out how much it is for just 1 dozen. So whenever you're dealing with a whole number, put it over 1. And if we're dealing with mixed numbers, we got to change it to an improper. So 3 times 1 is 3 plus 1 is 4. Divided by 2 over 1. And then we're dividing, so keep, change, flip. And then these can cross cancel by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. Multiply across. 2 times 1 is 2. And 3 times 1 is 3. So it's 2/3 flour for just 1 dozen cookies. But we don't want 1 dozen. We want 5 dozen. So I'm going to multiply it by 5. This can't cross cancel. That can't cross cancel. So we'll just multiply across. 2 times 5 is 10. 3 times 1 is 3. And I can't leave it like that. So take the top, divide it by the bottom. 3 goes into 10 3 times. 3 times 3 is 9. And when you subtract that, you get 1. So you put your remainder over what you divided by. So it's 3 1/3 cup of flour for 5 dozen cookies. Okay, so I'm going to put that on here. 3 1/3, which I see right here. So EH for 6. All right, number 7 says a backpacking club can average 2.5 miles per hour. At that rate, how long will it take for a hike of 8 3/4 miles? What do you think? A lot of you are saying not add or subtract. You know it's multiplying or dividing, but which one is it? Is it multiplying or is it dividing? And if it's dividing, which one is divided by what? Or is it multiplying? Okay, now some of you guys already figured it out. You can just look at these problems and you can know. Oh, you multiply, or oh, you divide. If you're like me and you kind of struggle with this, I look at the thing that has one term. So see how 8 3/4 miles has 1 unit, and then this has miles per hour. So this has 2 units. I start with the one that has 1 unit. Okay, so I'm going to start with this 8 3/4 miles. Then I use my thing that has 2 units, the miles per hour, and I put the like term diagonally across from each other so that they'll cancel out. Okay, so it's miles per hour. How many miles per hour was it? It was 2.5 miles per 1 hour. Okay, now whatever is across from each other, the numbers that are on top, those get multiplied. And then if anything's on the bottom, it's the top divided by the bottom numbers. So this kind of sets it up for me that it's 8 3/4 divided by 2.5. It just helps me visually see it if I'm always stuck over like, ooh, I know I multiply or divide, but I can't figure out which one. Start with the one that has singular units, and then use the one that has 2 units as your conversion thing. And then you're left with the unit that you want. It says, how long will it take, right? How many hours? So I end in hours, which answers the question of how long it took, and the miles canceled out. Okay, so again, start with the one that has 1 unit, then put the like units diagonally across from each other so that they'll cancel. This number went with the miles, one went with the hours. You're left with a unit of hours. Whatever's across from each other gets multiplied. Whatever's on top is divided by whatever's on the bottom. Okay, now that you have this, now I can actually do the math. 8 3/4 divided by 2.5. When you're dividing with mixed numbers, you want to change the mixed numbers to improper fractions. So you have 4 times 8 is 32. 32 plus 3 is 35. And then keep that denominator the same. 2 times 2 is 4, plus 1 is 5. And then now that they're singular fractions, you keep the first one the same. Change division to multiplication and flip that second fraction. Now, do you see anything that can cross cancel? Yeah. 5 can go into both 35 and 5, because 35 divided by 5 is 7, and 5 divided by 5 is 1. I find it easier to cross cancel because it's like reducing at the beginning so your numbers don't get so big. Okay, what can go into 2 and 4? 2 can. What's 4 divided by 2? 2. And what's 2 divided by 2? 1. Now when you multiply across, on top you have 7 times 1, which is 7, and on bottom 2 times 1 is 2. Now we can't leave it like that, so take the top, divide it by the bottom. 2 goes into 7 3 times, and that's 6. When you subtract that, you get 1, so you put your remainder over what you divided by. How long will it take? It's going to take 3.5 hours. So that is up here, EN. So for number 7, I'm going to put an EN right there. All right, moving right along. Number 8 says Lisa's working on plans for a 12-acre housing development. A park will cover 2.5 acres, and paved areas will take 1 3/4 acres. How many acres are left for home sites? What do you think? Try and see what you would do for that problem. Okay. Well, what's the total you have to work with? 12. And it says how many are left over, so you probably want to subtract eventually, right? So you want to subtract these two amounts from the overall 12. So let's start by adding those two. Okay, so for number 8, you have 2.5 plus, 1 3/4. Okay, so 2.5 plus 1 3/4. So first, when I'm adding, I need to find a common denominator. So 2 and 4 can both become 8. Now 4 times what is 8? 2. So that means 3 times 2 is 6. 2 times what is 8? 4. So 1 times 4 is 4. Now when you add the numerators, 4 and 6 make 10. Over 8 is your common denominator. Your whole numbers, 2 and 1, make 3. Now you can't leave this 10 eighths. I need to figure out what that is. 8 goes into 10 once. Subtract that, you get 2. So you have 2 eighths, or that is 1 and 1/4. Okay, so you still have the 3, but that 10/8 I'm going to replace with 1 1/4 that I just figured out up here. So now I combine the whole numbers. 3 and 1 make 4 and 1/4. Okay. Now that is what? That's the amount that they take up for the park and the paved areas. We want to know how much they have left for home sites. Well, the total is 12. So we want to subtract 4 1/4 and figure out how much is left over. So let's borrow from the whole number and then put 1 here, but as a fraction, and we're going to choose whatever this denominator is over itself. Okay, because 1, any number over itself is 1. And since you can choose any number you want, why not pick whatever that denominator is so you don't have more work to do, because you have to get common denominators. Now subtract your numerators. 4 minus 1 makes 3. And subtract your whole numbers. 11 minus 4 makes 7. So 7 3/4 acres is going to be left for the home sites. 7 3/4, which if we take a look, it's right here, NO. So number 8 is NO. All right, last one. It says Biff earned $45 working at Happy Days Drive-In. He spent 1/3 of the money on gas for his car and 1/5 of it on flowers for his girlfriend. How much money does he have left for the big date? What do you think? Okay. Well, when you have 1/3 of the money, what do you think you do with that? Add, subtract, multiply, or divide? 1/3 of this amount, we're going to multiply it, right? So 1/3 of what? The money that he had. So 45. So number 9, we have 1/3 of the $45 is spent on gas. Okay, so we can cross cancel, divide by 3, and 3 divided by 3 is 1. 45 divided by 3 is 15. So he spent $15 on gas. Is that all he spent, though? Nope. He also spent 1/5 of his paycheck on flowers. So 1/5 of that $45 he made was spent on flowers. So 5 can go into both of these. And 5 divided by 5 is 1. And 45 divided by 5 is 9. So 1 times 9 is 9. 1 times 1 is 1. 9 over 1 is just 9. So he spent 15 on gas, 9 on flowers. Let's see how much total that is. Okay, that's how much he spent. So now how much does he have left for the big date? Well, he started with 45. Subtract how much he spent. And that tells you how much money does he have left? $21. Okay. So 21 right here is how much money he has left. And that's MM. So for number 9, we're going to put an MM. Okay. And now you finished. Congratulations. That's the most important part. But if you're curious about the joke, it said, why does Zorna flunk the grammar test? It says she had no comma sense, because it's like common sense, but she had no comma sense because it was a grammar test. What a dad joke. All right, so hopefully the most important thing, not the joke, but that you guys actually got the math part right. That's what we care about. So if you did all those right, congratulations, my little mathematicians. You have mastered fractions and all different types of word problems.